Algebra is a combination of letters and numbers. Right, let's say 2x, so that's a form of an algebra. So algebra can be, combination of letters and numbers. So it can be 1, it can be algebraic expression. Okay, so what is an algebraic expression? So expression, these are algebraic statements, right? So these are algebraic statements. Example would be 2x, okay, let's say 2x squared plus 1. Alright, so that's an algebraic expression. Okay. 2, it can be equation, so algebraic equation. So it can be an equation, and an example could be 2x squared plus 1 equals 0. Right? So it's a type of an algebraic equation. So the difference between expression and equation is that the equation has an equal sign. So it's a statement and has the ends of the statement. This one is a statement, but it doesn't have the ends of the statement. So here you have the conclusion, there you don't have the conclusion. Alright, that's what I mean with the ends of the statement. Alright, 3, you can have algebraic formula. So I know you're familiar with, so our example could be, you are familiar with E equals mc squared. So this is a formula. Okay? An algebra can be an algebraic identity. So that means if we have, for example, we have let's say 2x plus 1, this could be equal to 2x plus 2, right? So this is an example of an algebraic identity. So an algebra can be somewhat like this, right? So it's an equation again, but when you are going to solve for this left side and the right side of the equation, you tend to have the same answer on both sides. Okay, let's take for example 2x squared plus 1. Okay, so we have this example. So there are terms that we need to remember and bear in mind for the whole algebraic journey that we are going to take. So you have to remember that these two here is called the coefficient, and the one right here is called constant. Alright, constant. So the one right here is called the constant. Two is known as the power, or you can say exponent. So the laws of exponents, if you could remember that, we are going to apply it also in algebra. Okay. The x right here is called the variable, so they can vary. So this means they can vary. They can vary on whatever number that you can put in there. So that means this could be, an application could be that the x right here is a variable. That means it could be mangoes, it could be bananas, how many buckets of flowers, and so on, like that. So this x here is known to be as variable. Okay, I would like to stress this. This one right over here, all of it separated by plus minus. This is called a term. So this one right here, as a constant, can also be a term. So if we're going to count how many terms is this? So this is a binomial which has two terms. So there are two terms here. One, the constant, and one term here. So this is an algebraic expression of two terms. So if we're going to describe it, so this is algebraic expression with two terms. Okay, so there are two terms there. The 2x squared is one term, and the constant, which is plus 1. So terms are separated by plus or minus. Okay, so this is the basic concept, the terms that we need to remember every time we are going to talk about algebra. This can be translated as a square of a number multiplied by 2 and added by 1. So a square of a number multiplied by 2 added by 1. So sometimes in our study of the algebra, our teachers would ask us to translate words into algebra, and algebra or algebraic expression into words, or it could be algebraic equation into words, or words into an algebraic formula or equation. Let's talk about substitution. I have here an example. It says find the area of a trapezium when A equals 5 and B equals 9 and H equals 3. So you have A there at the top, and then H and B. Now the formula of the trapezium is area is equal to A plus B times H over 2. Right. So substitution means we are going to replace the A here, the variable, with the numbers. You remember the word variable? What is that again? So it varies. So it varies on how much number, or it varies on what number are you going to plug in or replace it with. Okay. So if we have A equals 5, so that means 5 plus 9 times 3 over 2. So this means you will have 14 times 3 divided by 2, and then after that you are going to have 42 divided by 2, and the answer would be 21. Right, so the total area of this trapezium is 20. Okay, so again, what did we do with the substitution? Okay, so if the question says substitute the given values, that means you have the number 593, okay, will go to what letter they represent as variable. Okay, let's have a second example. Okay, so example number 2 here. So you have 2xyz divided by w. If x equals 2, y equals -3, z is equal to -4, and w equal to +3. Okay, so we plug in those values again to these letters here, so we will have 2 times 2, okay, times -3 times -4 divided by 3. Alright? So we have, if we're going to combine all that, you can have 4 -12, you will have 48. That's positive, and then you will have divided by 3. The answer would be 16. Okay, so what happened? So you have two negatives here. When they multiply, it becomes positive. So this is a 12 here times 4 here, so that will be 48, and it is positive. So you can, when we divide it, it would become 16, and 16 is our answer. Okay, so this is substitution. This is the basic concept of algebraic expression. So actually we are finding the value of an algebraic expression. So if we are substituting the numbers, so this one is an expression. The other one earlier is a formula, right? So that's a difference again. So this is an expression. It doesn't have any equal sign. This is how we substitute numbers. We just plug into those numbers into the variable.